Hello there, Graham. Here we have another demonstration for you. This is to demonstrate something that's slightly closer to the final product. It has a similar firmware to our development platform that we showed you in the previous demonstration. There are some additional features in there which we'll come to through the course of the demo. First of all, I'd like to move on to the PCBs here, just to give you a side-by-side comparison. On the right here, I can show you this is the old prototype that you supplied to us. In the middle here we have our development platform, and this is able to replace the old prototype. And on the right hand side here we have a single PCB. It's compact design, and this is what we're about to demonstrate to you. So if we can move over to the setup at the moment, we have our tank which is charged up to 200 psi. That's shown by the gauge. We have our sensor attached to the high pressure port of the regulator along with the gauge. The sensor is then wired into our device, which again is this single PCB design. It's just behind the cap. The device is powered by this variable power supply. This is able to simulate the battery voltage, which again we'll come to a bit later. This time we've also got a multimeter in place. This allows us to monitor the amount of power the device is consuming. At the moment it's 0.88 milliamps, which I can explain to you a bit later. But for the moment, if I start to drop the pressure, you should be able to see an indication on the gauge there. The thresholds are set as per the development platform, so at 133 bar we can expect to see our preliminary warning, which is flashing of the green LED, and it's quite slow flashing, and I'll just demonstrate that for you. And now we have our preliminary warning, and this is to indicate that the pressure in the tank has dropped to less than 2/3. We have our next threshold set at 1/3 of a tank. That is approximately 66 bar, and with that we can expect the amber LED to flash at 5 times the rate. It's considerably faster. And this is to indicate to terminate the dive. So now here we have our termination warning, and now we've also got a sleep feature implemented as well, and this is to enable you to disconnect the device from the tank without having to take it apart and disconnect the battery to switch it off. It automatically goes into a low power sleep mode when the pressure drops below 10 bars, and what will happen is 10 seconds after the pressure has dropped below 10 bars, the LEDs will switch off and the device will enter its lowest power state. So I'll just demonstrate that for you, dropping the pressure further. So the pressure's now gone to almost 0, and we can expect to see the device to go to sleep. Okay, so now the device has entered a sleep mode. If you take a note of the power consumption earlier as being 0.88, we're now at 0.07 or 0.08, and that is approximately 1/10 of the normal operating current. There's also a wake-up feature implemented, so that all you have to do to start the device is to attach it to a tank and drive the pressure up. Once it hits 10 bars, the device will wake up. The LEDs will blink in a sequence. Each LED will come on individually twice, and that is to indicate that the device is now operational again. After that you can expect to see the warning thresholds as the pressure ramps up, which I'll just demonstrate for you. Let's start to drive the pressure up now. now woken the device up, and we've entered our termination warning because the pressure is indicating less than 1/3 of a tank. And I can continue to drive the pressure up, and what you'll find is we'll move back into our preliminary warning area where the green LED will flash. And then moving on and up again, what we'll find is once we hit 133 bar, which is above 2/3 of a tank, the warnings will stop and the device will be operating normally, consuming about 10th-fold current of the sleep, as I explained earlier. There's also a battery monitor feature in there. Although not a battery meter, it will indicate when the battery is getting low. The threshold is set at 3.5 volts, which again I can demonstrate for you as I start to drop the voltage now. Once we hit below 3.5, this may take some time because there is an algorithm in there to prevent incorrect values, but now we have an indication that the battery is getting low. And then that will terminate as the voltage rises. Okay, so there we have our demo of the final product for you.